Good morning, students. We're going to be working on Unit 11, specifically 11.1, which talks about translations. We're going to be working on this with the assumption that you've already taken your notes on 11.1. If you haven't taken your notes, please stop what you're doing and go through the 5 or 6 problems of notes that are in section 11.1. This will then support those notes and allow you to get ready for taking the problems. But, basically, one of the things that we want to be able to talk about is the concept of this vector. So vector terminology is right here, all right? It's like a parenthesis, but it's a sideways V, like an arrow, with the horizontal movement corresponding to how many units right or left, depending if it's positive or negative. Right obviously is positive, left obviously then is negative. And then the second component is how many units the point moved up or down, depending if it's positive or negative again. And you can see that in our problems, the point P moves along this, what we call a vector. And that's very important once we get into like pre-calculus, calculus to Q. So basically it's the movement of this point to this point, just like if you were to take your phone, take your picture, take one finger and slide it all over the place, that's going to move the picture, okay? So it's very similar to what we are talking about there. The translation, in your vocabulary will move the entire picture. So in this case, that there's a segment. The translation moves along that vector, which moves this point and this point to relocate to make it look like this right there. Okay, so it's kind of what we're going to be looking at here. We always have an initial point and a terminal point. That initial point is determined about where there's no arrow. The terminal point where it ends up is going to be where we are looking at where it finishes. Okay, so the first example problem is set up to be able to figure out, we're going to name the vector and write it in its component form. All right. Basically, I'm just looking for the vector to be able to be named MQ or MN in this case. All right. And we're going to use that. So that's vector MN. And it's going to be denoted as array. And then we're going to name that vector. How many movement did it go right and left? So this particular vector moved 4 units to the right, and it went how many units up? 1, 2, 3, 4, 5, 6. It went 6 units up. So that vector is MN, and it will be called 4, 6 is the movement. All right. Now for this next problem, problem 2, notice that A is normally comes first in the alphabet, but in this case, the A is the terminal point because it ends in the arrow. B is the initial point. So we're going to actually name this vector BA so we can move in that direction. Direction is extremely important when we talk about velocity and calculus and things of that nature. So in this particular case, our movement left is going to be 1, 2, 3, 4, 5 left. So that's going to be a negative value. And then we're also going to move 1 down, which is a negative 1. So that vector is -5, -1. All right. Number 3, the initial point being K, the terminal point being J, which which has a movement left of 1, 2, 3, 4, 5 to the left, and 1, 2, 3 up, positive 3 up, and that creates that vector -5, 3. Okay, so that's how you name the vectors and write it in its component form. All right, so now in exercises 4 through 7, we're going to use the triangle ABC, and we're going to blow this up a little bit so we can see our points in ABC is going to be 1, 2. So that's going to be right here. Notice how each of these values is worth 2, so I got to take that into account. B is going to be 5, 1, which is going to be right there. And then C is going to be 5, 4, which is going to be right there. And we want to draw this triangle ABC. And then we're going to move ABC using the given vector. So number 4, all right, we're going to translate the ABC according to this vector, 4 left and 0 up. So if we want to make some notes over here, 4 left and 0 up, we're going to use that, and we're going to call it A prime, B prime, C prime. So we're going to move all of those points 4 units to the left. So from 1, that's going to go to -3. That's going to be, let's use a different color here so we can even see this a little bit better. All right, so we're going to move that point to right here. That's going to be A prime. This movement is going to be to right there. Nope, I went one too far over. It's going to be right there. C prime, and B is going to be also right there, right about here. So this particular triangle moves 4 left and 0 up. Okay, so now we're going to even use a different color here, trying not to confuse you. We'll call this A double prime, C double prime, or B double prime and C double prime. So we're going to move this to the left and 4 down. Okay, so again, we're moving from A. So A is going to move 2 left and 4 down. So this we're going to call A double prime. 2 left and 4 down is going to be right there. We're going to call this C double prime. 2 left and 4 down. It's going to be right there. B double prime. Okay, so that's how we are going to move that particular picture. And now we're getting a little. Now my graph is getting a little bit, I would say, a little clouded. So, we want to continue to practice these movements, but we're going to now erase these pictures just so I can get a little bit more clear picture of what's going on here. All right, so it's not going to allow me, it's not going to remember, I guess, moving that next one. So we're going to, again, we'll use a different color here. We'll use orange for this one. This is going to move 0 to the left or right, 0 left or right, whichever way you want to call it, and 5 down. Okay, So that's going to be no movement here, 0 to the right or left. We're just going to move A 5 units down, C 5 units down, and B 5 units down. That's 1, 3, 5. Oop. Is it right? 2, 4, 5. 2, 4, 5. Probably right there. I probably didn't do that very well. So this is 2, 4, 5 for C. B is 2, 4, 5 for B. And we call that triple prime. And we'll draw that triangle right there. Okay? So you get the idea of those movements. This is going to be, this movement will be, and I'm not going to do this movement, but this movement will be 1 to the right, 3 down. Okay, so all of those points from A when we moved 1 right, 3 down. So 1 right, 3 down will take us to right there for A. 1 right, 3 down will take us to right there for C. 1 right, 3 down will take us right there for B. And since we've done 4 movements, we'll call that quadruple prime. Normally we don't worry too much about moving things 4 different times, but you can see the whole picture of that triangle moves in that scenario. Okay, so that is how we use 4 through 7. And now this one's a little bit less time consuming, 8 and 9. What's going to happen in 8 and 9 is we are just going to create the rule for the translation of the entire quadrilateral. So PQRS, the one without the prime values here, is going to be the solid rectangle, and that solid rectangle gets moved to P prime, Q prime, R prime, S prime. Okay, so in our picture, that quadrilateral gets moved to right here. So essentially what happens is we're trying to figure out what's happening to move in that direction. Okay, so basically you only have, because we know the picture moves all together, we only need to figure out what's happening with 1 point. All right, now checking the scale again, making sure this is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So what's going to happen here is that movement that I'm going to create is going to be 1, 2, 3, 4 units to the right, and 1, 2, 3 units up. All right, so in number 8, we want to give the vector movement 4 positive and 3 positive movements. Okay, so that's how that works. In this particular piece, we're going to again go from P to P prime. So we're moving it in this direction. Very important to understand that we're moving it in that direction. We just have to figure out what that direction specifically is, and that's going to be 1 unit to the right and 1, 2, 3 units down. So that vector will be 1 right, and then 3 down is a negative distance or negative direction, so it's -3. Okay, here's another interesting way to write this in 10 and 11. Notice how in x comma y, for that x, we're going to use x, and then we're going to add 6 to it. So that's like a movement of 6 to the right. Okay, so if I were on a graph, that's going to be going to the right. This is going to be going down if you were on a graph because of the subtraction of 3, the addition of 6. So in this particular point, all we have to do is take the x value and add 6 to it. So that's going to be very simple. 4 plus 6 then equals 10. All right. And over to the side, I'll just kind of highlight the fact that that's what I did. 4 plus 6 is 10. And then 5 minus 3 is 2. So my new point is 10 comma 2. All right. So that's kind of where we're at here. 10 comma 2. All right. So again, this now is going to be movement according to this translation. So we're going to add 6 to this. So my new r prime is going to be equal to the point of 6. And then we're going to go negative 8. So that's kind of what we want to see in this. Doing number 12, it talks about a video game spaceship, 1 unit left, 4 units up. Then you move the spaceships 2 units left. So I'm not even sure where the heck this is. So where is this spaceship? I'm not sure. Is this the spaceship or is that the spaceship? I'm not sure. So basically let's say this was the spaceship. We would move it from here to here. And then we're going to move 2 to the left over here. So then the corresponding vector would be 3 left and 4 up. So it would be negative 3, 4. All right. So that's according to this. I don't know if this is a spaceship or if this is a spaceship, whatever the case may be. So that's how you do 11.1. We're going to link this video up to the PowerSchool page now, and we hope to see you soon.